Alright guys, welcome to this lesson on analyzing graphs. This is part one of two that we'll be doing this week: domain, range, and multiplicity. You've probably heard these words before. Really quick reminder, the domain is the set of all x values of a graph or a function, and then the range is the set of all y values. So domain is how far left the function goes and how far right the function goes. The range is an up and down, okay? Before we get too far into that, let's talk about even degree polynomial functions. Let's just review the end behavior rules for those. First of all, even degree polynomial functions, their highest exponent is an even number. Odd degree polynomial functions, their highest exponent is an odd number. Remember that even degree polynomials, the ends go the same direction, so they either both go up or they both go down. And with odd degree polynomial functions, one end will extend up and the other will go down. Okay? All right, let's move on. Okay, so domain. For all polynomial functions that we're going to be dealing with, the domain is all real numbers, which means we're going from negative infinity to positive infinity. And this is kind of how we write the the domain interval. So the lowest value of x and the highest value of x that is possible on the graph. And since it's negative, both infinities, one negative, one positive, we always put parentheses around those. So it's written exactly like you see it for that particular example. As far as range goes, odd degree polynomials are also going to have a range of negative infinity to positive infinity, which is all real numbers. Why is that true for odd degree polynomials? Well, remember that one end goes up forever and the other one goes down forever. So the one that goes up forever goes to positive infinity in the y direction, and the other one goes to negative infinity in the y direction. So another all real numbers answer possible. Okay. However, even degree polynomial functions, well, both ends either go up or they both go down, right? And if they go up, it's going to look something like this. It's going to bottom out at a number. The y value of this coordinate, the vertex, we'll call pound, that little hashtag symbol. And if both ends go down, then it's going to peak. And I'll just, we'll call it the same point, x comma hashtag. And if it opens up, the lowest value is going to be where it bottoms out. The highest value will be positive infinity. If it opens downward, then it tops off, and the lowest value is negative infinity, and the highest value will be the pound. Notice the brackets, those are very important. We use brackets around the numbers, parentheses around the infinities. All right, next slide. All right, so here's a couple examples on domain and range in interval notation. The first example is an even function. Hopefully you recognize that. Why? Because both of the ends go in the same direction. Bottoms out down here. We've got a low value of -1. We've got a high value of positive infinity. But domain, it goes left forever and right forever. Now, I know it's going up faster than it's going left or right, but it's still going forever in both directions. So the domain is from negative infinity to positive infinity. Another thing for that is all real numbers. That's just a little all real number symbol that you might see down the road. The range, the lowest value on that graph is -1, and the highest value it reaches is positive infinity. So the range is from everything from -1 to positive infinity for the y values. This over here is an odd function because one end goes up to positive infinity and the other one goes down to negative infinity. It goes left forever and it goes right forever. So the domain once again is all real numbers, negative infinity to positive infinity. And in this case, the range follows suit because one goes up forever and 1 goes down forever. So it's all real numbers again. And hopefully this is starting to click a little bit. All right, let's go on. All right, now looking at these two examples, again, we want to find the domain and the range, and we're going to use interval notation. All right. Well, these are, well, let's look at example 3. Example 3 goes left forever and right forever because we have these arrowheads. Now, yeah, it looks like it's going up, but it's never going to stop going left. It's never going to stop going right. It's just going to keep, it's just going to really, it's going to go up a lot faster than it goes to the right. So anyway, long story short is the domain is all real numbers. X can be anything it wants to be, but keep in mind that as X gets bigger, Y is going to get really big going to the left and the right because both of those ends will go to positive infinity. Now, the range, on the other hand, is limited because it bottoms out. It bottoms out here. And let's call that negative 35. So there's a minimum value here of like negative 35 for a Y. Okay. And that's, I don't know, that looks like maybe like negative 2.5 in the X. So if I come straight down, something like that. Anyway, the negative 2.5, that's part of the domain. That's not part of the range. But the minimum here is negative 35. That's the lowest value the graph has. And it goes on to positive infinity on both ends. So the highest Y value will be positive infinity. So there's the range for example 3. And example 4, it's similar, but both ends go down, and it looks like it's topping out at about 3. But anyway, domain real quick, negative infinity to positive infinity. Once again, it's going left and right forever, okay? But it's going to top out at 3, so the highest value it's going to reach is 3, so I put that on the right side, comma here, the lowest value is going to be negative infinity, and we always use the parentheses with that. So alrighty, there's a couple more examples, and let's move on. All right, so something else I wanted to make sure we talk about is the multiplicity. When a multiplicity of a 0 appears more than once, then we have certain things that can happen. So if we have an even degree multiplicity, as you can see here, then what we have is we have a bounce off of the x-axis. So in this case, you can see that at 4, we bounce off the x-axis. That means that x minus 4 is a factor of this polynomial twice. Okay. Well, this looks like a quadratic, so, oh, well, there it is, right there. You can put those two things together under a square, and you can see that we have the value 4 as a 0 twice. And in this case, it's a degree 2 polynomial. It's a quadratic, as far as we know. I mean, we don't see the entire graph, obviously, but we're assuming that it's not going to do any twists and turns beyond what we see on the graph, so we can pretty much assume that's a quadratic with its U shape like it is. Over here, we are crossing at -1, so x plus 1 is a 0, or a factor. -1 is the 0. X plus 1 is the factor. You can see that right here. Okay. And we also bounce off at 2, and you can see that we have x minus 2 as a factor twice because we're bouncing off the x-axis at 2. Okay, so we have 3 confirmed zeros, so at least it's a cubic. Well, that's as much as we can get from that graph. So the other idea is when we have odd degree multiplicity, we have a flattening out along the x-axis. So you can see here, it looks like we're going to bounce off, but then we don't, and we kind of continue through. So this is called a point of inflection. You know, if you get to calculus and stuff like that, you might talk more about those, but that's the general name, the commonly accepted name for mathematicians to call something like that, is a point of inflection. But that 0 basically, if you're doing that on the x-axis, then basically the factor x minus 2 is there 3 times. So this is at least a cubic polynomial, just looking at it. And if we look at the example over here, we have a point of inflection at 2 again, so x minus 2 is a factor 3 times, but we're also crossing through at 0, so x is a factor, and we're crossing through at negative 2, which means x plus 2 is a factor. So that's 1, 2, 3, 4, 5 factors, so this is a 5th degree polynomial from the graph. That point of inflection is 3 of them, the x, and then the x plus 2, well, oh yeah, no, that is a 1. That's actually a 1, because if we look at the scale here, every 2 blocks is worth 1, so we got to be careful. That's an x plus 1. And there's the factors there, okay? So 0 is at 0, negative 1, 2, and 2 has a multiplicity of 3. So the total degree of the function is 5. Okay, so in these couple examples, I want you to state the zeros with the multiplicity, the degree of the function, and write a possible equation. And we can also write the domain and the range for these, okay? Well, we have zeros at 2. There's a multiplicity of 2 there. We also have zeros at 4. This is a multiplicity of 3. So, and I think those are the only places it's crossing. So the degree of the function is 5 because we have 2 zeros from the 2 and 3 zeros from the 4. And, well, we're just going to add those together. The equation would be x minus 2. We're going to do that quantity squared, and x minus 4 cubed would be something like what equals f of x. The domain is always negative infinity to positive infinity unless we have some kind of breaks, and we don't. And one end is going down forever, and one end is going up forever. So once again, negative infinity to positive infinity. The negative infinity always goes on the left. I don't know that I ever mentioned that in any of the prior examples, but remember that, please. The negative infinity is the lowest possible value. Lowest possible value always goes on the left. Okay. Looking at example 2, we bounce off of negative 2. Okay, so we have 2 there. We bounce off at 0, and we have 2, so we have 2 there, and then we go through 1. So that's just a 1. So this, once again, is a degree of 5 because we have 2 plus 2 plus 1 factors. Possible equation, f of x equals, let's see, x plus 2 from the minus 2, 0, and that's a degree of 2. And then we have x squared, well, whatever. And we've got x minus 1 as well. Domain, negative infinity to positive infinity. Range, once again, negative infinity to positive infinity because one end goes up forever and one end goes down forever. All right, let's move on. All right, last slide, last 2 examples. State the zeros with multiplicity, degree, and write a possible equation. All right, well, we've got a 0 at negative 2. We got a 0 at positive 2. So we'll write those down. Those are multiplicity 1. So the degree of the function is 2. And the possible equation would be f of x equals x plus 2 times x minus 2. Okay. Domain, negative infinity to positive infinity. Down forever up to a 4. All right, and then final example, we have something at 2, 3, 4, 5, negative 2, 0, and 3. Negative 2, 0, and 3. Degree is, well, these are all multiplicity of 1, so the degree is 3. I'm just going to say multiplicity of 1. degree 3, so f of x could be equal to x plus 2 times x minus 3. Domain, negative infinity to positive infinity. And once again, negative infinity to positive infinity, because one end goes down forever and the other one goes up forever. All right, there's a bunch of examples. Good luck on the practice.